Okay, so this is this is going to be an easier tutorial for the Lewis method. So let's say you've got let's say you finished the first two blocks in the corners, and then that was pretty easy, and so you finished and then you figured out how to do the BD block, which might have been a little bit harder but made sense after a little while, and then the last two centers, which is really trivial in the Lewis method, and then you're left with this, which is L5E, which looks really scary at first. So the way that I do it is I do two edges at a time using these two pieces in the bottom. The problem is that's a little bit hard for people to get at first because how commutators work. So what I'm going to show you instead is I'm going to show you a faster, not a faster, but a more beginner-friendly way of doing L5E that you will. It is pretty much the equivalent of one at a time edge pairing if you're just starting reduction on 4x4. So I will do that. Okay, so in 4x4 when you're just starting edge pairing, what you do is, okay, so you get, let's pretend this piece is the buffer just because I'm going to be doing the same idea. So got this piece right here and I'm looking for it, and it's I suck at edge pairing, so don't roast. It's right there. And then I do that, and then I put any spot right here, and then like that. So you want to do that same idea. So let's do another one quick. Let's do this piece now. Right there. That, and then put any unpaired edge set in there. Anyway, so it's kind of the same idea with the one at a time edge pairing. It is a way of starting, but it's not a viable speed solving method. So what you want to do is there's kind of a flow chart of thinking. So step one is you want to look at one of these pieces. I will usually go with this one first, or it really depends, but I'll just do whichever one. So let's look at this one. This one's orange, yellow, and then you want to see if it's flipped or oriented. These two are both flipped, quote unquote, even though they're easier to execute. So this one, so if it's flipped, you want to AUF, adjust the U face until the place that it goes is in UF, up front. So then you do a slice move that brings this up, and then you look at both of the L and R pieces, and you say, okay, which one goes, which side has an unsolved piece? And then you do a commutator, like this is pretty much a sexy from the back. And then you would undo the slice move, and then undo the putting away move. So then you've got this piece solved. And now let's do that again with this one. So this, and I can see this piece is solved, so if I did this algorithm, which is a hedge slammer, it would mess it up. But since I can just do this, and then undo. So pretty much commutators come in A, B prime. So if you have, so in this commutator it would be A, let's say B, A prime, B prime. And now this one's solved, so now let's look for this piece. This piece goes right here, so on AUF. But let's say you've got, let's just go and flip this quick. Okay, so those are for pieces where they're flipped in this side like this. If they're oriented, quote unquote, just a little bit nicer. So if they're oriented, what you want to do is you want to AUF the place that it goes to the back, BU, and then do a double slice move on the slice that's on. So let's do it right here. And then instead of doing this, so then that's A. This would be A prime, B, but that would mess up this piece. So what we can do instead is this kind of algorithm, like you do in M2, then undo it like that. And now these bottom parts are flipped. Just do a two-edge flip for that. And now when you get only two edges, you want to get them opposite from each other, like that. And then the best way to do it is to put it so it's like this on one side, and then do a slice move, insert this edge again but flipped. So if you ever remember the Yao last two edges algorithm where you go like this, and you flip the edge and you undo it, then it's basically the same idea. So let me go and set it up quick. So let's say you have this right here. These two goes to here. What you do in Yao or in reduction is you do this. So this slices. This flips the edge in its place. This unslices. In Lewis, what you do is you do an inner slice, do the algorithm, uninner slice, undo the algorithm. So like first you have to commute, you have to get these opposite each other, which you can do like if they're right here, you can just do that, and then they're opposite each other. And then let's do the algorithm. So if there's a solve piece, you don't want to interrupt that piece, so like that. Do the algorithm, unslice, undo the algorithm. And then just keep doing that until you get some kind of parity, which you will get sometimes if you do this way. And then once these pieces are solved, you just insert the pair and then you're done. That is both one at a time last 5 edges, and second it is last 2 edges for noobs. So it's just spamming this until you get parity or you solve the cube. That's how I started doing it before I learned last 2 edges, which if you don't count these solving as a 3x3 algorithms, which you almost never get in Lewis, then this is the only amount of algorithms you need to learn. I still don't know this one. I should probably learn it eventually. So yeah, so that's the beginner's variant of last 5 edges. Like one at a time edge pairing is not something you want to do it's not something you want to keep doing. It's something that it's a habit that you want to not learn, so you want to figure out how commutators work like that, and then switch to for look or 2 at a time last 5 edges as quickly as possible. But that's just a way that you can start solving with it. So, see you guys.